Hey y'all, Bill Quirk with the Defensive Training Group and Shoot GTR. Out here today to do a quick video talking about red dots, specifically red dots on handguns. What this video is primarily going to cover is the installation and subsequent zeroing of the red dot on your handgun. Before I get to that, I'm going to talk a little bit, not in terrible detail, but just about red dots in general and the different mounting possibilities you may have when it comes to setting your handgun up to receive the red dot. The video is not primarily about that, so we're going to talk about some of those things. If you have questions about those specifics, feel free to reach out and we'll talk about it more in depth, either in an additional video or you can just ask questions and I'll answer them as they come in. So, red dots on handguns are becoming much more common, especially on your defensive everyday carry type of things. And there are three primary ways that you're going to see red dots mounted on pistols these days. So, this is what's called a direct mill. A gunsmith, in this case ATEI, has actually milled a pocket here with recoil lugs to accept the red dot. So the red dot will fit directly down here onto the top of the slide, and then you bolt it into place. As red dots become more common, you're starting to see factory offerings that are already cut to accept a red dot. And most of these will take some sort of adapter plate that bolts onto the slide, and that provides the footprint to receive the optic later on. And Walther's doing this, Glock's doing this. This is a Glock MOS. This is a Walther PDP, and you see it's got the plate up here underneath this Aimpoint Acro. In both these cases, these plates are made by a company called CH Precision Weapon Systems up in Georgia, and they specialize in doing adapter plates and make a really good product. The third option that you may see for some guns where you simply cannot mill a pocket into the slide because of the depth of the top of the slide, the internals, the configuration, all that kind of stuff, you may end up with what we have here, which is a dovetail mount. You push the rear side off and the adapter plate actually fits into the rear dovetail. Now these are viable, and for some guns this is the only thing that you're going to have. The problem, as you can see, is, or the challenge as you can see, is that it does set the optic quite a bit higher, comparatively speaking. If you look at this one, let me show you on one that's actually mounted. You can see how much lower this RMR on the Glock is mounted as opposed to this one on the FN. And that's going to give you a couple of things to think about. This, because it's higher, your height over bore is going to be significantly more, and there's going to be a little bit more muzzle flip as the centripetal forces of the slide reciprocates. Because this is higher, you're going to get a bit more of a whipping sensation. Not much, but there is some there. The big thing is it's going to put a bit more force on your optic, and you may experience a little bit less longevity with the optic, because these do receive a lot of G-force as the gun is cycling, as that slide whipping back and forth. And the lower you mount it, the less that's going to be transferred to the optic itself. So, another thing I want to talk about just real quick that you may hear about and may be kind of confused about is the question of a closed emitter versus an open emitter optic. And basically all this means is, this is the Trijicon RMR, one of the more popular, the more common, been around a long time. This is what I carried on duty for all of my time running a red dot equipped pistol. I started carrying a red dot equipped pistol back in 2008 on duty, and I always used an RMR. That's in Florida with the heat and the humidity, and never had a problem. But what we're talking about here, you can see down in here, the emitter, the LED that actually shines up onto the lens here on the inside of the window is exposed. So if you got mud or water or anything in there, there is a possibility that that emitter could become occluded and you wouldn't see your dot. That's why we run backup irons. But like I said, I have carried these for years and years and years. I fought people, I've fallen in the mud more than once, chasing bad guys and so on and so forth, and I just never had a problem with it. The other thing that is possible that could happen is, because the lens is not protected from the elements, you may get some condensation on the inside there. And if you get out of a cold car with air conditioning into the hot, humid Florida sun, you may get some fogging there. And again, that's something that's talked about. I have not personally experienced that as a problem. It's happened maybe once, maybe twice. especially with a concealed carry weapon where it's carried against your body heat will go a long way to mitigating that and making it not be an issue. And if it does become an issue, you just take your finger and you just swipe off the condensation. It's no big deal. But this is an open emitter, and this is a lot of the Holosuns, the Trijicon products, they're open emitters. Then we also have a closed emitter. And so you can see this is a fully enclosed box. There's a lens back here and a lens up on the front here that protects all of that stuff, secures the emitter so that nothing can get in there and potentially block it. You still have a risk of condensation on the exterior of your two lenses. And like I said, hasn't really been a problem in my experience, and it's something that's easy to fix if it does become a problem. Simply swipe the lens off there. But all things being equal, a closed emitter is probably a better idea. I wouldn't worry about it too much. The downside is you do get a bigger footprint here as compared to an RMR, which not a huge deal. The weight's basically insignificant. The weight difference is basically insignificant. This corner might print a little bit if it's carried concealed. I've noticed that on mine. But, you know, probably a better idea. I wouldn't worry about it if you've got an RMR or a Holosun 507 or a 508 that's an open emitter. You don't need to run out and get a 509T or an Acro P1. I think it'll be just fine for you. Your mileage may vary. So those are just a couple of things to think about, just to kind of define our terms and give us a base from where to proceed now. Different mounting systems. If you've got an older pistol that is not pre-cut from the factory for a red dot, direct mill is going to be your only real option. If you've got a newer gun that is already cut, then obviously the plate system is your only option because you can't really re-mill that. I suppose you could if you really wanted to put a lot of money into it, but it's not necessary. Either system can be very good. Direct mill limits you to one footprint generally, and that's the nice thing about the Holosuns. The 407 and the 507 are the same footprint and the 508 are the same footprint as the RMR and the SRO. But you can't go from a milled RMR footprint to, say, a milled Delta Point Pro or an Acro or anything like that. You're kind of stuck with what you've cut the slide for. Your only option is to go and buy a new slide or get a new gun. The adapter system does give you the ability, as new optics come out, or if you decide you want to go from an open to a closed emitter, they give you the opportunity to take the plate off and put a new plate on there. But you're also complicating the system because now you've got multiple interface points. You've got a plate attached to the slide and then an optic attached to the plate. So you have double the amount of screws that you have to worry about coming loose and making sure that they're secured properly. So if you've got one optic that you're going to stick with, going direct mill, probably a better idea. ATEI, the company that's done all my direct mill stuff here, are, in my opinion, the best in the business for various reasons. One is that they will put these recoil bosses in there, and the pocket is actually milled not just for the brand of optic, but for your specific optic. And that's important because that good fit with these recoil bosses, you're going to get the best longevity out of your optic. It's going to minimize the transference of those forces we talked about, those G forces, as the slide reciprocates. If you think you might want to change optics as something new comes out, or if your gun is already cut, then obviously you're going to be more interested in the plate system, and that's fine as well. I run several plate systems. The big thing there, for both really, but particularly for the plate system, is the installation. So I mentioned backup irons a second ago. If you're using the weapon as a defensive tool, backup irons, in my opinion, are critical. There's been some controversy recently. There was an article in a national publication that said that backup irons are no longer necessary. It's not that optics will fail and backup irons are forever, because I've seen plenty of irons break, get knocked around, get pushed out of their dovetails. It's that you've got two redundant sighting systems that are independent from one another that will give you that advantage in case something does go wrong. So if the front sight snaps off and you still got your red dot. The red dot comes off, you've got your irons. And I've had that happen in class where I'm running demos and my sight sheared, my red dot sheared, and I just kept running the drill using my irons. It transitioned very, very quickly. You do need to practice with both systems so that you can go back and forth as necessary. If you only run the red dot, never practice with your irons, you're not going to make that transition if the situation ever requires it, or vice versa. I don't know why you do it vice versa, but you take my meaning. So now we're going to talk about the installation process, and the installation process is critical for the overall longevity and effectiveness of your optic. We need to make sure that it is mounted correctly, because an improper mount, several bad things can happen. The screws can shear, the screws can rip out, the optic will be loose, so your zero is going to be fluctuating. You're going to be exposing the optic to more G-force if it can move back and forth, and that may reduce the longevity, the service life of the optic. So very important that we do this correctly. The basic procedure between a direct mill and a plate system, they're going to be comparable, but there are a couple of noticeable differences. So in the case of like the Glock slide, the overall width here side to side is such that if you're running an RMR, which has a battery accessed from the bottom of the optic, you're going to need to utilize what's called a sealing plate. And this is a little product from Trijicon, other companies make them too, that fits into the recess. This is one that's still in the wrapper. It's called a sealing plate. And what this does is it expands the side-to-side profile, so when you mount the optic, it fits all the way around the perimeter of the optic where there's a gasket, which will keep any kind of moisture from leaching underneath and getting into your electronics and affecting the battery connectivity and all that kind of stuff. So you got to have one of these if you're running an RMR. If you're running a hollow sun, which has a side load battery, so the bottom is solid, or an SRO, or any of the closed emitters are going to have a different system, then you don't need this. If you're running a plate system, then generally speaking, the plate footprint is going to be of sufficient width to provide that seal, and you don't need the additional sealing plate for an RMR. And like I said, the hollow suns, SROs, you don't have to worry about that anyway. So, talking about the direct mill, when we go to mount the optic on here, first thing we're going to do is test our fit. Make sure everything goes on correctly, that there aren't any tolerance issues or anything like that. Make sure the screws will fit cleanly into these holes, that the thread pitches match and whatnot. And then, once that's all done, we're going to go ahead and thoroughly degrease our screws and our screw holes. And so what I'll do is take pipe cleaner and douse it in fingernail polish remover or acetone, anything like that, and just drive it all the way through here to make sure that there's no residual oil left down in those screw holes. With the plate system, same idea. I'm going to test fit the plate, and then once that's all good, I'm going to degrease both the screw holes where the plate will get mounted, and I also want to degrease the holes where the optic is going to be mounted as well. Make sure everything is nice and clean, just get any residual oil off it. So this is our plate system after everything is degreased. For the plate system, we're now going to attach the plate to the slide itself. So for these screws, what we're going to use is our red Loctite, our semi-permanent, stronger Loctite. Put just a little bit on there, work the screw in, and I'll work it in, go back and forth to make sure that that Loctite is thoroughly distributed throughout the screw and throughout the hole. And then crank it down, get it properly torqued. Torque is a big thing that you need to pay attention to, and the instructions from the manufacturer will include recommended torque settings. You can get an actual torque wrench that will fit these types of torques and hex head screws. I've learned over years of doing this just to do it by feel, and I know where it needs to be. But torque is important. You don't want to over torque it because you could strip the head or even snap the screw in some cases, and that's going to cause a real problem trying to get that repaired. So this will be red Loctite. So after we've got the plate securely attached and whatnot, now we're going to mount the optic to the plate, or in the case of the direct mill, directly to the slide. So again, we've already done our test fit. We'll set this down. We'll take our mounting screws, and on the mounting screws to attach the optic to either the plate or to the slide, you're going to want to use blue Loctite, especially with your RMR, because at some point you're going to have to take that off in order to change out the battery. Less of an issue with the hollow suns because this battery, like I said, is a side load, or the SROs because that's top load. But still, it's generally advisable to use blue Loctite when you're securing the optic to the plate or to the slide rather than red. Just a little bit on there. Tighten those screws down, again, obeying the factory torque settings. And then once that's all done and everything's in place, snug down the way that you want it, properly torqued, let it sit for 24 hours is best to make sure that that Loctite cures before you shoot the gun. You want to give it a good time for it to set and harden so that you're not prematurely shooting the gun and it's just going to start loosening back out. So I've run a bunch of plate systems and I've run a lot of direct mills. And if you do it this way, if you pay attention to what you're doing, test your fit, degrease everything, put the right type of Loctite on the various screws, and then make sure it's torqued down to an appropriate spec, you should be good and you won't have any problems, and they'll last you a long time without any issues. So that's some basic information about different red dot types and different mounting options. And most importantly, we've talked now about the installation process. So our next video is going to cover the zeroing process, which is also something I get a lot of questions about, and the pros and cons of different zeros and the tips and tricks that will give you the best performance out of your red dot once you get it set and ready to go. So we'll see you next time. This is Bill Quirk with DTG and Shoot GTR. Y'all stay safe.